Hello everyone, in this video I'm going to talk about how to plan IP addressing for an organization, or in other words, how to divide a network into subnets. Dividing a network into subnets is related to planning IP addresses for an organization, because a big organization is likely to start with a big network and then divide the network into smaller networks, which we call subnets. So in this video I'm going to talk about how to do that. The very first thing you need to determine is how many networks or subnets do you need. It can be based on different locations. Each location can have one network, or a location can have also multiple subnets or multiple networks. First, you need to figure out how many networks you want to create for the organization. Then for each network you need to determine how many IP addresses do you need. We'll talk in detail about the number of IP addresses required for a network. Let's say the first location 1, has 2 servers, one firewall with 2 active interfaces, one router with 2 active interfaces, one management interface for switch, 12 IP phones, and 12 workstations. So the total number of device IP required will be 2 plus 2 plus 2 plus 1 plus 12 plus 12, which is 31. That means that we need 31 IP addresses to be assigned to different devices. However, in every network or subnet, you know that there are 2 IP addresses that need to be there but cannot be assigned to a host. One of them is the network address and the other one is the broadcast address. The total number of required IP addresses in the network will be 31 plus 2, 33. Now let's say the organization has 2 more locations. Location 2 requires 105 IP addresses, and location 3 will need 20 IP addresses. The number of IP addresses in a network or subnet must be a power of 2. That means you can have a network or subnet with 2 IP addresses, or 4 IP addresses, or 8 IP addresses, or 16, or 32, or 64, or 128, or 256. Look at the requirement of 3 different locations. The first location needs 33 IP addresses, but the number of IP addresses in a network must be a power of 2. So to meet the requirements of 33 IP addresses, we have to use a 64 IP address block for location 1. For location 2, we need to have at least 105 IP addresses. We have to use 128 IP address block for location 2. For location 3, we need 20 IP addresses. The IP address block has to be a 32 IP address block. For location 1, the IP address block that we can use is 64 IP address block, even though we need 33 IP addresses. For location 2, we have to use a 128 IP address block, even though we need only 105 IP addresses. For location 3, we have to use a 32 IP address block, even though we need 20 IP addresses. Now, in any network, how many IP addresses are there? You can find that information easily. Let's take the network address 192.168.30.0/24. That means the subnet mask is 255.255.255.0, which gives us 24 ones in the subnet mask when you convert this to binary, and 8 zeros in the subnet mask when you convert the subnet mask in binary. So we have 8 zeros in the subnet mask. That gives us 8 host bits, and 8 host bits gives us 2 to the power 8 equals 256 IP addresses. As the given network is 192.168.30.0, that means the very first IP address in the network is 30.0, and we have 256 IP addresses. So the IP address range from 192.168.30.0 and goes up to 192.168.30.255. Total 256 IP addresses. Let's take another example. Let's say the network address given to you is 192.168.30.128/24. This is in Class C network, and this is not a full Class C network. This is a subnet of Class C network. As you can see that the subnet mask is not /24, it's /25, and the IP address starts from 128. There are 25 network bits in this subnet mask, and that gives us 32 minus 25 equals 7 host bits. If we have 7 host bits, then the number of IP addresses in this network is 2 to the power 7 equals to 128. So the range of IP addresses in this network starts from 192.168.30.128 as given, and we have 28 IP addresses, so 128 plus 128 is 256, but since the first IP address .128 is inclusive, so the last IP address in this subnet will be 192.168.30.255. Let's go back to our original problem where we have an organization with 3 locations, location 1, 2, and 3. Also, let's say that given network is 192.168.30.0 with /24 as the subnet mask. So the number of IP addresses in the given network is 256, ranging from 192.168.30.0 and ends at 192.168.30.255. First, the number of IP addresses that you have, you need to divide into 2 equal blocks of IP addresses. You have 256 IP addresses with /24 subnet mask ranging from 30.0 goes up to 30.255. If you split it into 2 equal halves, you will end up with 128 IP addresses in each half. And when you split a network into 2 equal halves, your subnet mask changes and the number of network bits increase by 1. So /24 becomes /25 in both subnets. Since the number of IP addresses in each half is 128 and the IP addresses start from 30.0, so one half of the block will range from 30.0 and goes up to 30.127, making 128 IP addresses. The very next IP address after 30.127 is 30.128, and that's the start of the second half of this IP block, and it goes up to 30.255. That was the last IP address in the original block. Also on the right side we have 128 IP addresses. So 256 IP addresses are divided into 2 equal halves, 128 in one half, 128 in other half. Now the IP range on one half goes from 30.0 and up to 30.127, and the other half goes from 30.128 and goes up to 30.255. When you divide 256 IP addresses into 2 equal halves, your original 256 IP address block doesn't exist anymore. You just split it into 2 and put into different blocks. Now you can split these 128 IP address blocks into equal halves again. You can split both of them, you can split one of them as you wish. Look at our requirement. Location 2 requires the IP address block of 128 IP address, and we have 2 blocks of 128 IP addresses right now. So we can assign one of these blocks to location 2. Let's say we assign the right side block of 128 IP addresses to location 2. That means the IP address for location 2 will start from 192.168.30.128 and it will end at 192.168.30.255. Now the other block we can split it again, and if we do split it again, then we will have 64 IP address in one block and 64 IP address in another block. So the left side block IP address will start from 192.168.30.0, and since there are 64 IP addresses in this block, so it will end at 192.168.30.63, making 64 IP addresses. The right side block of these 64 IP addresses will start from the very next IP address, which is 192.168.30.64, and will end at 192.168.30.127. When you split 128 IP address block into two equal halves, making 64 in each of them, your original 128 IP address block doesn't exist anymore. You just split it into two. In this situation, let's look at the detail of three IP address blocks that we have. One of them is 64 IP address block, the other one is also 64, and the third one is 128 that we assigned to location 2. Now if we look overall these IP address blocks, then you see that all of the IP address blocks are not equal. That means the number of IP addresses in each of them are not exactly the same. So this is a scenario when we have unequal subnets. Look at our requirements. We have 128 IP address block that already assigned to location 2. We have 64 IP address block, and we need 64 IP address block for location 1. So we can assign one of these 64 IP address blocks for location 1. Let's assign the left side 64 IP address block. So the remaining IP address block is a 64 IP address block that starts from 192.168.30.64. We can split this 64 IP address block again into two equal halves, and that gives us 32 IP address block, and that gives us two 32 IP address blocks. The first one will start at 192.168.30.64. The right side block will start at 192.168.30.96 and will go up to 192.168.30.127, giving us total 32 IP address blocks. When you split the 64 IP address block in two equal halves, then the 64 IP address blocks doesn't exist anymore. Now we have 4 different IP address blocks. One of them is 128 IP address block, and we have assigned it to location 2. Another is 64 IP address block, and we have assigned it for location 1. And we have 32 IP address blocks. We need a 32 IP address block for location 3. So we can assign any of these two IP address blocks that meet the requirements, and the remaining 32 IP address block will be unused. So all of our 3 locations got IP address blocks according to their requirements. We can summarize the detail of different subnets that we allocated to different locations as shown in this table. For location 1, we had 31 devices IP addresses. For location 2, we had 103 device IP addresses. For location 3, we had 18 device IP addresses. We allocated a 64 IP block for location 1, 128 IP block for location 2, and 32 IP block for location 3. The IP address range for location 1 was 192.168.30.0 to 192.168.30.63. For location 2, we assigned the IP range starting from 192.168.30.128 and goes up to 192.168.30.255. For location 3, we assigned the IP range starting from 192.168.30.64 and goes up to 192.168.30.95. The subnet mask for location 1 was /26, which is the same as 255.255.255.192. For location 2, the subnet mask was /25, which is the same as 255.255.255.128. And for location 3, we had the subnet mask of /27, which is the same as 255.255.255.224. In a previous video, you saw how to divide a network into equal subnets. In this video, you saw how to divide a network into unequal subnets. In dividing unequal subnets, we start from the given network address and then split the network into two equal halves. Now we can split each subnets into two equal halves and repeat this process. In this example, if we divide the given network into two equal halves, then we get two subnets of size 128 IP addresses in each of them. And then if we divide both of these subnets again into two equal halves, then we get four subnets, 64 IP addresses in each of them. Please notice that when we got four subnets, and so this became equal subnet. Essentially, dividing a network by splitting into two doesn't necessarily means you are dividing into unequal subnets, but that's the way to make unequal subnets, as we saw in this example. However, in the same process, you can also make equal subnets, such as in this example. I hope you understood how to divide a network into different subnets, whether it's equal or unequal. Thank you.